Hi everyone, Krishna this side. In this video, I'll be covering this Leetcode problem 440, get smallest in lexicographical order. Okay, so it is basically hard problem from the Leetcode, and let us go through the problem statement first, what we have given and how to approach this particular problem that we will discuss in this video. So given two integers n and k, return the kth lexicographically smallest integer in range 1 to n. Okay, so yes, it looks like it is a similar problem what we have done yesterday, but basically they are asking for get the smallest integer from that lexicographical order. Okay, so if we think that the range from 1 to n, whatever the number that we get, lexicographically orders are like this way: 1, 10, 11, 12, 13. Then after 13, since the range is still 13, so we cannot go beyond 13. We start with 2, 3, 4, 5, 6, 7, 8, 9. Okay, now they are asking for the second smallest one, so 10 is something what we will going to get from this one, and that is something what we have to print into the output. Okay, so okay, question is straightforward, and if we think about the solutions, the first idea that we get is like we can sort these arrays and we can convert them. We can simply sort the arrays, we get the range, and we can loop and we can get the number. Okay, this will going to take n log n, and the time complexity is also again n log n. Space complexity is going to be n log n. So yes, that is the thing, like we can solve it with the help of it, but further we can improve it with the help of priority queue. We can just set the priority queues length to, I mean, 2, and we keep on sorting the data in the priority queue based on the smallest one. The moment we reach the second largest one, so it is like whatever the element that we get, the second one, that is something what we have to write. Okay, so yes, with this priority queue also, it is going to be log n log k again. Still, the time complexity is what we reduced from n log n to n log k. But yes, that is another approach. And if we discuss about the third approach, it is like the DFS approach that we tried yesterday itself, and it was basically taking only big O of n space when we try to go into the depth of each elements, and we keep on collecting them, and instead of collection of them, we can check that the moment we reach the counter whatever we are trying to get, we can add it into the answer and break it from that loop, and we can print it. Okay, that is another approach that we can try it out, and it was basically taking big O of n, right? But if we look into the constraint, they have given that the n's range is actually less than or equals to 10 to the power of 9. So whatever the approaches we tried, right, big O of n log n, n log k, or even big O of n, all those approaches won't work for this type of constraint. Okay, see, if they have given 10 to the power of 6, till that we can use all those approaches, even big O of n or n log n, those solution would have been considered. But any number that is beyond this 10 to the power of 6, we have to think in a such a way that the solution should write whatever the approaches that we are trying to do. It should be taking the time complexity as a constant, or even we can consider it in log n time. Okay, so yes, all those approaches won't work. Okay, whatever we tried. So DFS approach, you guys can watch the yesterday's video. You will get the idea like what I was trying to discuss. So that way you can try it. It will basically take B of n with, sorry, the time complexity, and that way we can solve it. But still, U of n is not sufficient for this constraint. Okay, so if we see here, right, if n is actually less than or equals to 10, we can think that the required time complexity is going to be n factorial if it is less than 20. In the constraint, if it is mentioned 2 to the power of n, time complexity we can consider if less than 500, and cube is something expected 5,000. If it is 5,000, less than 5,000, n square is expected. I mean that this all the solution will get expected. Okay, if it is less than 10 to the power of 6, we have to think that it should be like n log n, or even we have to write the solution sometimes in big O of n. But if it is larger, then we have to definitely go for time complexity, which will be going to be log n, or even it is a constant one. Okay, yeah, this is something what we have to remember every time when we try to solve any problems. So since the constraint is pretty much larger, and if we try with big O of n, that will also going to give us the TLE. Okay. So yes, how to solve this particular problem, right? So whatever we tried the DFS tree like structure, right? With that only we'll try to think like how can we improve the solution. Okay, so let us see here. If they have given n is actually 25, k is actually 15, the 15 smallest number is what we have to figure out. So the range starts from 110 and it goes till 25. After 25 also 3, 4, 5, 6, 7, 8, 9, those elements will also been considered because those all are less than this 25. Okay, I didn't get added those in this particular one because it was getting exceeded. But yes, after 25 also 3, 4, 5, 6, 7, 8, 9, those will also still be there. Okay, in this range. So now they are asking for 15th one. So if we go from this one, it is basically this one. This is the answer that we have to get. Okay. The idea is straightforward now. So what we can try to do is if we look into this recursion tree that we tried yesterday, so we start with 1. After 1, we goes for 10. If again after 10, it is going to be 100 next smallest one. But we check that if it is less than 25 or not, right? So if it is not, so why to consider even 100, right? So we simply go back and from all this rest, whatever the 100, 101, this will not get considered. From after 10, it is the next smallest one is going to be 11. Okay. This is clear for us. After 11, it is going to be 12, 13, 14 till it is lying between this range n is equals to 25. All the elements less than this 25 will be considered. Once all the possibilities for 1 is done, we will shift our focus to 2. That is what it is happening, right? So 1, 10, 11, 12, 13 till 19. After 19 we are going for 2. So yes, there is idea that with this help of this one, what we are seeing is until and unless we get all the counts which starts with prefix 1, the digits count, we will not going to move our focus to 2. So yes, now here we can get this idea that okay, what if we can get the counters of all the digit that starts with 1 as a prefix. The moment we get these counters, we check simply that if it is less than this 15 or not. If it is less than 15, that means the answer is basically not lying in this range. Okay, from 1 till 19, whatever the elements that we have, the answer is not definitely not in this particular range. So what we do is we will shift our focus to 2. Okay, now from 2, all the possibilities from 2 to 3. Okay, 3 is again next element, right? After 25, the next is going to be 3, obviously, right? So because the range is still from 1 to 25 and 25 is the last element that we can get with this 2. Okay, so after 25 it is going to be 3. So what we do is basically check the counts between 2 to 3, how many digits that are there. Okay, the moment we get the counter, we check that with this whatever the value that we have. So previously whatever the counters that we got, we simply subtract those counters value from this k, and whatever the new updated counter that we have, we simply again try to check with that new updated counter this whatever the counts that we get from the 2. Okay, now the moment we see that whatever the count value that we are getting, if it is getting exceeded than this k, that means the answer is basically lying in this 2's range only. Okay, whatever the digits that start with this true prefix, the answer is actually relying in that one. So here also we can say that the answer is basically 22, right? That is giving us clarity. So instead of moving further, now we will go depth into this 2. Okay, so if the answer would have lied in this range, okay, if they would have asked second largest second smallest integer, that is basically 10, right? After 1 it is going to be 10, correct? So if they would have asked second largest one, the count from this one is basically 11. If we consider this range between 1 to 19, this 10 to 19 is basically 10 and this 1 is basically 1. So in total they are 11. The counter is something what we got 11, and basically 11 is actually greater than this 2. If what if we consider k is actually 2? Okay, for that condition I am discussing about this. So k was actually 2 and the counter that we got was 11. So answer is actually relying in this range. So we will not shift our focus to 2, but instead what we do is we go downside and check between this 10 and 11. Okay, now here is the thing. Okay, since the range is actually less than 25, so we are not bothering about 100, but before this 11, okay, the smallest digits are actually with lexicographical order are 100. If 1000 is also there in the range, that is the next one is the fourth, the smallest one is 1000. Then after 1000 this 101 is going to be there. Okay, that is how things works, right? So what we do is basically we check between this 10 and 11 which is the smallest one, or sorry, between 10 and 11 how many counts that we get. Okay, based on the 10, the recursion tree that we get. Okay, that is what we are doing. Okay, from between 1 and 2 we check if the answer is actually lying in this range. We check now from between 10 and 11. If the answer is not lying, what we do is basically we check between 11 and 12. If still it is not lying, that means it should be between 12 to 13. If it is not, still 13 to 14. So as we will check till 18 to 19. The moment we get the answer, we simply return from there. That is the idea that we are trying to do right over here. Okay, so we first check horizontally. If answer is lying, we go into this previous range. If not, we again check horizontally between 2 to 3. If the answer is lying, we'll go downside and we check between their relations. The moment we see that if the answer is at any point in time, if let us suppose the range is quite big and the answer is lying between 2 to 20 to 21, so we go again downside. Okay, that is the simple thing we are trying to see, and we check horizontally again in that range if it is lying. Okay, that is the idea that we are getting right over here. So yes, okay, we now get the idea that the simple intuition is something what we got. How to solve this one, right? Like between 1 to 2, we try to get all the counts, possibly the counts, how many counts that we have. Okay, it doesn't matter how we will try to get the counts. Okay, so we simply what we can do is between 1 to 2. How many digits that are there which starts with 1, that is something what we try to figure out. So only one is there, right? Now once that is done, what we do is between 10 to 20, how many digits which starts with 1, that is something what we try to figure out, right? Because that is the next range that we will be going to hit after 19. Okay, after 19 we go for 2, but 2 is something what we already checked between this relation, so we can go for 20. Now the moment we check between this, we check between 100 to 200, how many digits that starts with 1. Okay, all the 100 till 119 basically starts with 1, and those priorities should come before this one, right? And if they are actually lying in this range, we can simply get the counters. Okay, that is what we are trying to do. We are not bothering about like how, okay, the answer would have lied in this range, but still we are trying to figure out like how counts and all. So that is the another case, but currently we are trying to see like how many digits that start with 1, all the counters before this 2, all those counters is something what we are trying to figure out. Okay, the moment we get the counters, we simply check with this k, and if it is actually less than this k, we simply shift our focus between 2 to 3. Okay, that is the first thing that we got. Okay, if what if the answer is actually lying in this range? Okay, if the answer is lying in this range, what we do is basically change this. Current is actually pointing to 1, so we multiply it with 10 so that the current will try to focus in this range. Okay, so between 10 and 11 first we check, and between 100 and 110 we check. Okay, if the answer is actually lying in this range, we simply shift our focus between these, right? That is something what we have to try to do. Okay, we keep on checking in smaller ranges further. The moment we realize that okay, the answer is actually lying in this range only, so we keep on shifting our focus on the downside. If not, we shift our focus to the horizontally side. Okay, so first we check between 1 and 2. If the answer is lying in this range, we go downside, we check in this range. If the answer is lying, we go downside. If it is in this range, we go downside and we check in this particular range, whatever the range that we are getting. If not, we check between the next range, okay, 11 and 12. That is the idea that we are having. Let me write down the solution first, because by explaining this way, it won't get pretty much clear. So let us suppose the current is basically pointing to 1, because from 1 only we are starting, and this current is something what we will return at the end. So what if n is actually 1? Okay, so k should let us decrement this k to 1, and this k is something what it should be always greater than 0. Okay, we are doing some calculation and the k value should be greater than 0. Since k is actually reduced to -1, now k is basically 0 for this particular inputs example. So n is actually 1, so current is basically pointing to 1, k actually got reduced to 0. We will not enter into this while loop and we will simply return the answer that we have. Okay, for that we are running this while loop and we are decrementing the counter to -1. Okay, now currently the current is pointing to 1. Okay, we got that k is actually got updated. So let us take this example only. Okay, the range is actually 110. Let me write down that. Okay, 110. So here only I'll explain you 14, 15, 16, 17. Then okay, sorry, after 13 it is not right. The range is still 13. then it is 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is the range that we have, and the current is actually pointing to 1. So 1 is something what we have considered. So reduce the k's value to 1. Okay, k was previously 2 and it got reduced to 1 now based on this current logic. Now we check that k is greater than 0 because k's value is 1. So only one element is something what we have to figure out for this particular example. So what we do is we will define here long count, because the range is actually getting till 10 to the power of 9. So we might, the moment we try to get this count, we might get out of bound. So let us define the long as count, and get count is the function that we will be having, which will return us the counts of all the digits that start with a particular prefix. Okay, now the get count is there. Here we pass this current, and n is something what we will pass. Okay, let us define this get count function first. Long get count. And here, what is the first thing? It is the current int n. So the idea is, now we are, what we are trying to do, we are trying to check between this range, right? Like 1 to 2. Look, current is actually 1. So the next is basically going to be current plus 1. Okay. See, even if we go downside, right? The moment we go at 10, what we are trying to check, we are trying to check between 10 and 11 how many counts we are getting. So simply, that's why I just added 1 to it. Okay, in the next I just added current plus 1. The moment we add this current plus 1, we got the next. Now we got this boundaries between 1 to whatever the next that we have, between 1 to 2, how many counts that we get, which starts with 1, the digits that we get. Okay, we will run a while loop. This current whatever we have should be less than or equals to n, because the moment we realize, right, like it is, the range is actually till 13. Do we have to look for 14, 15, 16? No, right? So that's why I just added this, whatever the current that we are at, it should be less than or equals to n. Okay, so what is the there should be a count another here, and let us define it as a long count. Should be at default 0. Let's change all this one. Okay, this current also I just want to update it to long to avoid overflow conditions. Now it is actually long. Okay, now this count is something what we have to update. So what we do is, in the count we keep on adding the values between 1 and 2, how many counts that we get. So it is like between next minus what is this current, current is 1. So it is like 2 minus 1, between this one how many digits that start with 1. Only one is right, single is right. So that is something what we have added. Now the count is basically 1. The moment we get that, now we have to check between the range 10 to 20. So current is basically shifted to we just simply multiply it with 10, and next is also getting multiplied it with 20. Okay, now we are looking between 10 to 20 how many digits that start with actually 10, but here that start with 1. Okay, but here the problem is this 20 is basically greater than this current. Okay, so what we do is basically we will add here math dot main between this n plus 1 comma whatever the next that we got. Okay, so see why I did n plus 1 means, like, we have n is actually 13, correct? So 13 minus the current value is 10. That is what we have done here. So 13 minus 10 is basically 3 is what the counter that we get. But is it considering 10? No, right? So we have to consider 10, 11, 12, 13. So the count is actually 4. But if I just consider n minus current, it is going to give 3. So the count should be basically considering including all this one. Okay, 10 to 13. So that's why I added n plus 1 minus the current value. So the count is basically 4 now. Sorry, it was 3 earlier. Sorry, it was earlier 1, because between 1 to 2 it was only single element. Between 10 to now 13 is what we are having this range. We cannot go till 20 because the range is actually relying till 13. So 10 to 13 we got 4. So 4 is something what we added into the count. So the count is now 5. So 5 digits is something what we got between 1 to 2. How it is so, right? So see, 1 is already considered, so k got reduced to 1. Now between 10 to 2, 2 is also getting included in this one. Okay, 2 is also getting included. So that's why in total, if we see 1, 2, 3, 4, 5, total 5 is something what we got, and k already got reduced to -1. So here now 2 also should get reduced. The first thing is what we check is here in this if condition, what we do is if whatever the count that we got, if this is basically exceeding this k, okay, if it is basically getting exceeded, or else if it is less than or equals to k, okay, let us think about exceeding this k. If it is getting exceeded, then this k, as I already said, 2 is getting included in this one. Okay, so let us suppose the count is basically currently what we got, the count was from this function, it was 5. 5 is something what we got. 5 is basically getting exceeded than this k. What we do is we simply shift our focus from this current to next one, that is 2. Sorry, from this current is basically pointing to 1, and whatever the count that we got, it is basically getting sorry, it should be less than or equals to k, right? So if it is less than or equals to k, whatever the count that we got from this one range, if it is less than or equals to the k's value, that means this whatever the range that we tried figuring out, the answer is not actually lying in that range. Okay, so what we can do is we can simply shift our focus from 20. So 2 is also getting included because less than or equals to k is something what I have written. Okay, so the current is basically pointing to this, k get reduced from this count, or else in the else condition what we do is current is something what we focus it, shift our focus to there, and k is got reduced to -1. Okay, this else condition is something what this both the condition I'll explain you guys simply. It is pretty much straightforward. Okay, see, the count is from this function, the count is what we got 5. Okay, let me write down over here. 5 is something what we got. Okay, and count is 5. So the k value is basically now it is actually 1 because it got reduced to 1, right? That is something what we already know. It got reduced to -1. So k is actually 1. What we can do is we will check that count if it is less than or equals to k. It is not, right? So what we do is we go into the else condition. That means whatever the range that we got, total 5, the answer is actually relying in that one because it is getting exceeded. The k, second largest element that we are trying to figure out is actually relying in this answer only. So what we do is basically we shift our focus from 1 to 2, 1 to 10 instead of 1 to 2. And this if condition basically shifting the focus, if it is exceeding, then we are shifting our focus from 1 to 2. Okay. And now in the else condition, we enter shift our focus from this current 1 to 10, and count get decremented because 10 is something what we are at. Okay. From 10 to 11, we again try to check the range, the count that we are trying to figure out. The count is something what we get 1, but before that only the k got reduced to 0. Okay, the moment we shift, and current is actually at 10. Okay, for this particular example, when we are discussing about this one, this we get out of this while loop, and that is something what we are trying to return. Okay, so yes, that's all from this particular problem. It is bit tricky to understand, tricky to solve as well, until and unless you try to write down all the different type of test case scenarios. Till that point, it will feel like it is actually getting difficult. But yes, it is straightforward as well. The moment we realize that like how this if and else conditions we are trying to write, we are basically shifting our focus from horizontally or vertically. That is what we are trying to do. But we need to just consider few of the edge cases while writing this if and while loop. Then once if you write the solution, you understand it. In the future time, if let us suppose in an interview also, if they ask this question, you at least get the intuition that okay, you can try it out, and that time you can figure out all the different edge cases, and then only you can write the solution. Okay, that's all from this particular video. This will take, if we consider this one, we are shifting our focus horizontally, that will take big of log n, and downward also we are trying to get this one from this while loop, so it is also log n. So in total it is going to be log n into log n. Okay, that is the time study which will be getting accepted. Okay, let us try to run this code as well. Okay, there are cases where we are getting wrong. So if let us see what is it is printing, it is printing 22, but we are expecting 21. So that means there is some uh, issue with this one particular one. If we look into this while loop, the current is basically, let us suppose if it is 10 and 13 is what we are demanding. So of course it is in a range, so we are going inside there. I don't think there is problem with this particular loop. Let us see here, k got decremented, k is actually greater than 1. So long count is what we are trying to get current, and we are shifting our focus. Next is something what we got updated, so it should be multiplied with 10. Okay, it shouldn't be multiplied with 10. Okay, sorry for that blunder. But yes, of course, we are trying to see ranges between 10 to 20, then 100 to 200, right? Whatever the next that we have, we are simply multiplying it with 10. Okay, I think that was the mistake. So let us try to run the code. Yes, it got accepted. Let us submit this code as well. I already explained you the time complexity. It still took some time to explain it, but I'm not sure if you guys get it. Try to write down the edge cases and try to figure out what we are trying to do right over here in this code. Just remember this particular diagram. We are going shifting our focus either horizontally or vertically. Okay, and with that you might get idea. So that's all from this particular video. I hope you guys got some learning. Thank you for watching this video. Bye.